right, good morning, ladies and gentlemen. This is Mr. Kenton here, getting started for a new lesson in physical science where we're going to be looking at and continuing our discussion about matter, physical and chemical properties and changes, things like that. And so I am picking up where we left off, and what we've been discussing are these different types of matter. Remember, we've said that matter is any object that has mass and occupies space or has a volume. And we came up with a classification where we could put things in these categories as either pure substances, elements, and compounds, and then mixtures, homogeneous and heterogeneous. Well, when we start to look at those particular categories, we could also say that matter is going to exist in different states. So, like, when I use the term state, it's essentially the condition at which it's in, right? And so, when we start talking about matter, you can hear me talk about phases of matter, or you could hear me say states of matter. And this is going to refer to the different ways in which matter can exist. Okay, and so in terms of what we look at, it's going to come in one of four forms. There are four types of matter. There's solids, liquids, gases, and then there's plasma. Now, for the scope of what we're going to be looking at, ladies and gentlemen, we're only going to need to familiarize ourselves with solids, liquids, and gases. A lot of chemistry focuses on how these solids, liquids, and gases interact. Plasma, while not necessarily new, not a lot of chemical processes take place in the plasma phase. And so that's why we're going to kind of shift towards only looking at solids, liquids, and gases. Okay, and so as we are looking at these states of matter, there's certain things that I want you guys to be able to describe and to know about each of them. So let's take a look at what each of those things are within solids, liquids, and gases. So when we talk about solids, now we could think of things that are solid, like, for example, the laptop that I'm using, the table that my laptop is sitting on, even this book that I'm holding in my hand, it's an example of something that's a solid. Now, when we start to look at how a solid is made up, or how the particles that make it up, how the matter that makes it up is arranged at this atomic level, this very small level, what we should note is that the particles are very close together. And I want to draw your attention to this image that's to the right over here. And so what you should notice is you've got these different circles. These represent the atoms that make up the solid. And notice how they're touching each other. It's very rigid. There's a specific structure to it. Okay? And so that is something that's going to be definitive, or that we could use as descriptive, that describes what solids look like at the atomic level. Now, because all particles are constantly moving, in solids, that's also true. Now, we don't typically see those movements, but for a solid, what happens is that when the particles get excited, they start vibrating back and forth. Now, another characteristic of solids is that they have a definite shape and volume. And so what I mean by that is that their shape and volume are fixed. Okay, like, for example, when I talk about this calculator, right, there aren't a lot of different ways in which I can change the shape of this calculator. Now, I could break the calculator and change its shape, but that's not exactly what we mean for solids. So for solids, they have a definite shape. It's more rigid, and they have a specific volume. Same thing would be true with this calculator. It has a very specific volume. It doesn't change very much, right? So definite shape and definite volume are these things that are indicative of something that's a solid. Now let's take a look at something that is a liquid. Now, liquids, what's going to happen when we start to think about what's going on with the particles that make them up is they tend to have this structure here. And something that you should notice, at least about this particular diagram, is that yes, the particles are still kind of close to each other, but hopefully what you recognize from this image as compared to the previous one, there's more space between those particles, and there's more movement, and there's more opportunities for those particles to move as well. Now, we could classify this as the particles are a little bit more disorganized. They're not as rigid in their structure. And in terms of the movement of the particular particles, the particles are able to move over each other. And so when you think about the ability of, for example, for liquids to be poured, like if you're going to pour yourself a glass of water, like if you take a pitcher and you pour water, the reason why the water is able to be poured in the first place is because these particles can move over each other, which allows for that pouring to be able to happen. Now, when we talk about liquids, give me a second, let me get my water bottle. When we talk about liquids, what we do know is that they have a definite volume. And so what I mean by definite volume is that they take the volume, or they're only going to occupy the amount of space that exists for that particular substance. So for example, you've got my water bottle here. And when I look at my water bottle, it's telling me that it's got about 550 milliliters or 18 ounces of water in it, right? So it doesn't matter how big or small this container is. Like if I get a bigger container that can hold more water, the amount of water that's in here is still 550 milliliters or 18 ounces. And so if I pour it into a larger container, it's still going to have that same volume. I hope that makes sense. Now, this last particular piece is that liquids do not have a definite shape. And so what I mean by that is that a liquid is going to take the shape of the container that it's in. Now, for example, with my water bottle again, my water bottle is shaped most like a cylinder. And so currently, the water that's in my bottle is taking on the shape of this cylinder. Now, if I were to pour my water into a box, let's say that it was like a square box, then what would happen is as I fill up the box with the water is going to take on the shape of that box, and it's going to form a square as well. And so liquids do not have that definite shape unlike solids. I hope that makes sense. Then lastly, we have gases. Now, to be aware, for the image's sake, there were less particles that were drawn here, but there could be the same number of atoms that are here. But what I want you to notice is there is a lot more space between the individual particles. Okay, and that's something that's very indicative, that's very descriptive of what gases look like at this level. And what's truly going on here is that the particles that make up a gas, they have a lot more freedom to move, and therefore they have no order or structure, right? And you think about the air that we breathe, it's made up of multiple gases. Well, those gases are just freely moving in the air around us, okay? And so as we move from the solid, the liquid to the gas phase, we get less and less structure, and we have more and more movement of the particles that make up that particular substance. Now, when we look at gases, gases have no definite volume and no definite shape. And so what I mean by that is that gases will take on the volume of whatever container that they're in. So for example, like if we think about the classroom that I'm currently in, if we had just some amount of gas, we would say that the volume of that gas would be equal to the volume of this room. So the amount of space the gas takes up is going to be equal to the amount of space that this room occupies. Likewise, gases, they don't have a definite shape, so they're going to take on whatever shape their container is, right? If we think about it, this is how balloons work, right? You blow up a balloon, the gas fills up the space within inside of it, the balloon takes that shape. However, you can mold the balloon into different shapes as well, and so the gas will then take on that particular shape. So that would be our solids, liquids, and our gases, giving you some of those descriptions and also giving you these particle representations. These are going to be good things to go back to and be familiar with, because one thing you should be able to do is to draw a particle representation of a solid, liquid, and a gas. Now, when we start to talk about, we've got these different states, solid, liquid, and gas. Well, we have what can be called phase changes or changes in state. So we can have substances that can go from a solid to a liquid, for example, or from a liquid to a gas, or go the opposite direction, gas to a liquid, liquid to a solid, or going from a solid directly to a gas, or gas directly to a solid. Now, in order for these changes in state or phase changes to occur, what has to happen is that whatever substance it is that we're studying, in order for it to undergo that change in state or phase, energy must be added or released by the object in order for that to happen. Now, for phase changes, most of the time, what that's going to correspond to is that heat gets added to your particular substance. And as heat is being added, or as heat is being released, the substance that you're looking at is going to change from, let's say, a solid to a liquid. Now, to understand what's going on during a phase change, we need to understand that there are attractions between the atoms. Think about those little circles or those spheres that were drawn in those representations. There are attractions between those two particles. So there's like this force that's keeping them close together. And so during a phase change, when it's going from one state to another, what's happening is that those attractions are either causing the particles to move closer together, if it's releasing energy, or if you're putting in energy, it's going to cause them to move apart. Now, a good example of this is when a solid melts. Like think about ice. So when ice melts and gets converted into liquid water, what's happening is that the potential energy of the particles is increasing. And so what that's communicating, those particles are getting farther and farther apart. So now those particles have more and more potential energy. So they have energy that's available to do something. Now, the last thing I want to mention here is that during a phase change, when you start to look at what's going on, during a phase change, the temperature of a substance does not change during that time period, because what's happening is that the heat energy that's going into this particular substance is being used to increase that potential energy. So instead of seeing a temperature change, we just see that the particles are getting farther and farther apart. All right. Now, when we talk about different types of phase changes, they fall into two categories. There are phase changes where energy is added to the substance, and then there's phase changes that occur when energy is released by the substance. Now, the phase changes that occur when energy is added, that's going to be melting or vaporization, or you might have heard of the term boiling, right? So melting is what occurs when a solid gets converted into a liquid. So think about what happens when ice gets melted and converted into liquid water. Now, vaporization takes place when a liquid gets changed to a gas. Now, if any of you guys like to cook, and when you're cooking pasta, one thing that you do is it tells you that you need to boil the water so that the pasta can cook. Well, boiling water is when you're taking the liquid water that's in your container and you're converting it to that gas phase. Now, in both melting and vaporization or boiling, what's going to happen is that the particles that make up that substance are going to get farther apart, and therefore the potential energy is going to increase. Now, when energy is released, here's what could happen. You could have either freezing or condensation. So when freezing happens, what happens is the liquid changes over and the particles come together, they form that rigid structure to take on the solid state. So think about this is what happens in the winter when we have snow or it starts raining or sleeting and it's cold enough outside, the water hits the surface of the road and then it freezes overnight, making it difficult to drive. Now, condensation, this occurs when a gas changes to a liquid. And this is most prominent, like let's say that you have a cold drink, for example. So you've got the water vapor that's in the air, and as things are cooling off, it turns into a liquid. And so like on the side of a glass, you get those like water beads that show up there. It's because the water vapor around it has cooled off to the point where it's changed to a liquid. Now, during both freezing and condensation, the particles that make up your substance are going to get closer together, and so there's going to be a decrease in potential energy. All right, 2 more things and then we're going to be done with this video. So one last note on phase changes. There's a special phase change called evaporation. Now, evaporation is what takes place when a liquid gets converted or changes to the gas phase, but it's not at the temperature at which it's supposed to vaporize or boil. And so, for example, like I list here, it says this process, energy is still going into the substance because it's coming in from the surroundings, whether the room that it's in or what have you. And so energy is still going into the substance, which is causing the particles to gain more energy. And the best example I can think of here is if you have some sort of liquid or like water that's in an open container. If you leave it for a couple of hours, what you'll start to notice is that water is actually going to the water level is going to lower over time. And that's because energy is still going into the water. And so it's going to cause it to evaporate. And so what's going on at the particle level, atoms at the surface of the liquid, at the top of the liquid, are changing into the gas phase and they're escaping into the environment that they're in. And so evaporation is going from a liquid to a gas, but it's not the same thing as like boiling or vaporization. I just wanted to make that distinction here. All right. And so to kind of summarize these things, to put a visual to what I'm talking about, you should notice that this is what's called a heating curve. And so on a heating curve, we always want to take a look at our axes when we're looking at graphs. So we'll notice that time is on the x-axis and that temperature is on the y-axis, right? So as we go across, more time has gone by. As we move up, temperature is increasing. And so what you'll notice is at the blue segments, it says that we're heating a specific state. So this first segment would be heating the solid. This next blue segment would be heating the liquid. And this last blue segment would be heating the gas. And so notice that these blue segments, that according to the graph, the temperature is going up. Now, at the red sections, notice that it's a horizontal line. These represent our phase changes. So this would be melting, and this would be boiling. Now notice that as we go across, time is increasing, but notice that temperature is remaining constant during that particular point on this graph. So temperature does not change during melting or boiling, right? Now, just as we can have a heating curve, we can also have a cooling curve. And so a cooling curve is essentially the exact opposite. You start off in the gas phase, so the temperature is high. You decrease the temperature, it undergoes a phase change, condenses. You cool the liquid, it undergoes a phase change by freezing, and then it's all in the solid phase. Okay, so that's our video that talks about states of matter. Now, what I would like for you guys to do, I'm going to have a Google form that's available to you, and I want you to make sure that after you watch this video, you complete that Google form, and I'm going to have some questions that are embedded in there that are going to give you some practice on the differences between these states of matter to kind of test what did you learn from the video. So guys, thank you so much for watching this. I look forward to seeing you guys again soon. Take care.